This is SpaceTime, Series 29, Episode 76, for broadcast on the 26th of June 2026. Coming up on SpaceTime, a possible supernova remnant discovered at the centre of our galaxy, a new quantum view of the Big Bang, and work begins on a new Western Australian ground station for missions to the Moon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers may have discovered a supernova remnant near the supermassive black hole at the centre of our galaxy. Supernova remnants are the expanding remains of exploded stars. They provide elements like iron, oxygen and silicon, which are critical for the formation of planets and for life as we know it. Nuclear fusion at the cores of stars creates elements from the hydrogen and helium that were abundant at the beginning of the universe. When massive stars explode at the end of their lives as supernovae, they send out these newly synthesized elements into the interstellar space medium, providing material for future generations of stars and planets. This new supernova remnant, if confirmed, would be one of the nearest ever seen to Sagittarius A star, the supermassive black hole at the centre of the Milky Way galaxy, an exotic region crammed with massive stars, long threads of magnetic fields, and dense clouds of gas, all orbiting rapidly around the galactic centre. The new findings, reported in the Astrophysical Journal, are based on data gathered by NASA's Chandra X-ray Space Telescope, the European Space Agency's XMM Newton Space Telescope, as well as ground-based radio observations by the Meerkat Telescope in South Africa and optical images from the Pan-STARRS telescopes in Hawaii. Astronomers detected X-rays emanating from a blob buried deep within a large cloud of expanding gas known as an H2 region surrounding a massive young star located some 26,000 light-years away. This blob's thought to be the remains of a star that exploded as a supernova. The surrounding cloud of gas, called Sagittarius C, is a bright radio source. It's composed of ionized hydrogen, that is, hydrogen which has had its electrons stripped away. If this is indeed a supernova remnant, then it's expanding at well over 3 million kilometres an hour and is at least 1,700 years old. Previous observations had shown evidence of an expanding shell of gas surrounding Sagittarius C, and this gave astronomers a hint that a stellar explosion may well have occurred there. An alternative explanation for the X-ray blob is that the hot gas comes from a collection of massive stars in the region. But the authors of this study think that's unlikely because the X-ray emission from the blob is more than 10 times brighter than the X-ray emissions from large known stellar clusters with bright massive stars. The authors searched the X-ray data looking for signs of increased amounts of key elements in the remnant which would have been caused by the supernova blasting them into space. The trouble is they didn't find any, but that could simply imply that the stellar debris already mixed into the surrounding gas. This report from NASA TV.
Sagittarius C. Astronomers may have found a supernova remnant near the Milky Way's center. If confirmed, this would be one of the closest known to the galaxy's giant black hole. NASA's Chandra and ESA's XMM Newton found evidence for this exploded star. Supernova remnants are critical for planets and life as we know it to form and thrive.
The discovery is another example of the incredible science still being achieved by NASA's Chandra Space Telescope.
In Florence, Italy, in the year 1609, the world changed. Using a small telescope, Galileo proved that the Earth is not distinct from the universe, but part of it. And he showed that there is much more to the universe than we see with the naked eye. In the 20th century, astronomers made another revolutionary discovery, that optical telescopes reveal only a portion of the universe. Telescopes sensitive to invisible wavelengths of light have detected microwave radiation from the Big Bang, infrared radiation from protoplanetary disks around stars, and X-rays from explosions produced by black holes.
We have booster ignition and liftoff of Columbia, reaching new heights for women in X-ray astronomy.
On July 23, 1999, the most powerful X-ray telescope ever made began its exploration of the hot universe.
NASA's Chandra X-ray Observatory, in orbit since 1999, studies the high-energy universe, where black holes, exploded stars, and mysterious matter hold sway. X-ray telescopes like Chandra are not like telescopes you find in backyards or at the local observatory. In addition to being above the Earth's atmosphere, they need to have special mirrors to detect the X-rays that pass through most objects. Let's listen to scientist Martin Elvis explain more about Chandra's technology.
The main thing Chandra does is take these superb, sharp images. How does it do that? Well, X-ray telescopes are different from optical telescopes. They have a very different shape. Although, in fact, they're really reflecting light in just the same way as optical light. It's just that with X-rays, you have to coax them into being reflected. If you have a normal mirror, you look at yourself in the mirror and the light's going in and straight back, so it's being bounced through 180 degrees. If you try that with X-rays, they just get absorbed. But you can get specular reflection if you come into a grazing angle of a degree or less. Once you get that specular reflection, X-rays act just like optical light. You can concentrate them and focus them, no problem. Trouble is, you're only bending the light through 1 degree on each reflection. We end up having 2 reflections in our mirrors. That means that the light's only coming together very, very slowly, so we tend to have very long telescopes, most of it being just empty space. We're just waiting for the light to converge down to its focus. The bad thing about these mirrors is you're looking almost edge or end on at a cylinder, so the area of glass that the light's reflecting off is only a thin annulus. So what we do is pile a whole bunch of telescopes nested one inside the other to build up the area. But basically you still have to polish 100 times as much glass as you would for a normal optical telescope. So this 1.2 meter diameter Chandra mirror is focusing light down onto an exquisite point just 1,000th of an inch across. That's why Chandra's powerful.
In addition to its special mirrors, Chandra also travels in an unusual orbit around the Earth. Unlike its partner mission, the Hubble Space Telescope, Chandra cannot be serviced by astronauts. That's because it does not circle relatively closely to Earth as Hubble does. Martin explains more about why Chandra travels in unusual circles, or, more accurately, ellipses.
Chandra doesn't just go above the atmosphere, it goes 1/3 of the way to the moon, getting well away from the Earth. But can't get above the atmosphere twice, so why do we bother? The answer is to be much more efficient at observing. It's only a small telescope and we tend to have to observe a long time. But if we're down where the space station is, then wherever you want to look, half the time the Earth is in the way. Not what you want if you're looking with an X-ray telescope. So instead, if you can afford the energy to push you way out there, the Earth looks very small and you can point almost anywhere without it getting in the way. That's very useful for many observations, but mainly it doubles the efficiency of Chandra.
Now that we've heard a little about how Chandra works, let's listen to Martin give us an introduction to how X-rays are produced in the universe.
There are 3 different ways you can get matter to be that hot. One is simply an explosion, like a supernova, such as the one in 1987 in the Large Magellanic Cloud. What we see there is very fast-moving gas that's hit material on the outside and is now glowing with a shock at a few million degrees. The next way you can make X-rays is a more complicated process, and that's by having very fast-moving charged particles in a magnetic field. Basic law of physics is that any charged particle moving in a magnetic field gets swirled around, and in doing so it's accelerating around a bend, and accelerating charge radiates. It turns out there are lots of places in the universe where we get magnetic fields and very fast-moving, we call them relativistic particles. They're moving very close to the speed of light. The Crab Nebula, for instance, is powered by a pulsar at the center, which has so much energy in it that the little wisps and things you see in the image, which look like they're sort of swirling around the nebula, they aren't swirling at all. They're moving outwards at extraordinary velocities. This type of X-ray making mechanism we find very commonly also in quasars and blazars, which are things with these huge jets that come out, maybe many times the size of a whole galaxy, and these are powered in X-rays by the same mechanism. The third way of making X-rays is perhaps the least likely. It's just dropping something down a hole. If you have a lot of mass somewhere, like a planet, or better still a neutron star or a black hole, and you drop something in, then it speeds up, and when it hits the surface or some other gas coming from a different direction, it heats up. A spaceship re-entering the Earth's atmosphere does the same thing. It starts glowing very hot. The spacecraft is generating heat through friction with the air and slowing down. And that's just transferring the energy of its motion into heat. So it's a very simple process, really. It just turns out that most of the X-ray sources in the sky are powered this way.
This is SpaceTime. Still to come, a new quantum view of the Big Bang And work now underway on a new Western Australian ground station for future missions to the moon. All that and more still to come on SpaceTime. A new study could change what science knows about the Big Bang and the earliest moments of cosmic history. The findings, reported in the journal Physical Review Letters, provides a new way to understand how the universe began 13.8 billion years ago and how its rapid early expansion, known as cosmic inflation, could have arisen naturally from a deeper, more complete theory of quantum gravity. To reach their conclusions, the authors developed a new way to try and combine gravity with quantum physics. Most existing explanations for the Big Bang rely on Albert Einstein's theory of gravity. And while general relativity has been very successful for more than a century, describing the universe on the cosmic scale, it breaks down at the extreme conditions that existed at the birth of the universe. To address this problem, the authors used what they call quadratic quantum gravity, which they say remains mathematically consistent even at extreme high energies, similar to the kinds which would have been present during the Big Bang. They claim their approach offers a more unified picture that connects the earliest moments of the universe to the well-tested cosmology scientists observe today. They found that the Big Bang's early expansion, this cosmic inflation, can emerge naturally from this simple, consistent theory of quantum gravity without adding any extra ingredients. Now, this early burst of expansion is a central idea in modern cosmology because it helps to explain why the universe today looks pretty much the same in all directions. Their model also predicts a minimum amount of primordial gravitational waves, which are tiny ripples in space-time geometry created in the first moments after the Big Bang. Now, if we can eventually detect them, these signals would offer a rare chance to test ideas about the universe's quantum origins. The study's lead author, Naeesh Afshordi from the University of Waterloo, says the work shows that the universe's explosive early growth could come directly from a deeper understanding of the theory of gravity itself. Instead of adding new pieces to Einstein's theory, the rapid expansion emerges naturally once gravity is treated in a way that remains consistent at extremely high energies. Afshordi says that even though the model deals with incredibly high energies, it leads to clear predictions that today's experiments could already start looking for. Upcoming galaxy surveys, cosmic microwave background experiments, and gravitational wave detectors are now becoming sensitive enough to test ideas that were once purely theoretical. At the same time, scientists are finding limitations to the simplest models of the early universe's expansion, increasing the need for new approaches grounded in fundamental physics. This is SpaceTime. Still to come, construction begins on a new Western Australian ground station for future missions to the moon. And later in the science report, Japan sending a transformer robot to the lunar surface. All that and more still to come on SpaceTime. Construction work's now begun on Kongsberg's new 20-metre parabolic dish antenna ground station being established at Mullewa in outback Western Australia. The company is partnering with Starsight to build and operate the new facility 450 kilometres north of Perth. Starsight will then manage and maintain the installation, which is designed to support lunar missions. Kongsberg already operates over 300 antennas at 28 sites around the world, including a mid-latitude dish at Peterborough in South Australia's mid-north that's designed to provide coverage across the entire Oceania region, and a 20-metre antenna optimised for deep space communications at Kojarina, east of Geraldton. That Kojarina site also houses the classified Australian and US national security and defence ground stations as part of the Signals Intelligence and Echelon networks. Echelon's better known to civilians as Five Eyes. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. American and Dutch researchers say a man with severe paralysis and speech difficulties caused by ALS has been able to use an implanted brain interface to operate a computer and speech system independently now for almost 2 years. The team implanted electrodes into an area of the man's brain related to speech, which then decoded the data they received into text and cursor control. The man's now used this system for more than 3,800 hours, communicating over 183,000 sentences at an average of 56 words per minute. A report in the journal Nature says the research shows that these kinds of brain-computer interfaces can be used without the need of assistance and for extended periods of time. Scientists are raising the alarm as a powerful heat wave in Antarctica is continuing to push temperatures up more than 20 degrees Celsius above average for this time of year. On June the 6th, researchers at Argentina's Esperanza base on the Trinity Peninsula recorded a temperature of 15.4 degrees Celsius, breaking the previous June record by more than 2 degrees Celsius. Now you've got to remember, it's the middle of the Southern Hemisphere winter right now, so the anomaly of warm weather soaking the Antarctic Peninsula is a clear warning that things simply aren't right. The warmth is linked to stronger westerly winds influenced by climate change. It's triggered rain on glaciers and widespread surface melting during what should be the depths of Antarctica's cold season. Antarctica's ice is critical for global sea surface stability, and scientists are continuing to monitor vulnerable areas such as the Thwaites Glacier. Meanwhile, the Collins Glacier has already seen warm rain and active melting replace the usually deep snow and solid ice which is normally experienced this time of year. While a single heat wave won't cause Antarctica's massive ice sheets to collapse, these extreme warm conditions are becoming more frequent, and that's a concern. A new study warns that people who eat more ultra-processed foods have a higher risk of heart disease and death. The findings, reported in the European Heart Journal, highlights the risk of obesity, diabetes, hypertension, chronic kidney disease, and death from heart disease, all of which have now been linked to eating large amounts of ultra-processed foods. The authors are calling on doctors to talk to their patients about how much ultra-processed food they're eating and give advice on how to reduce this intake. A palm-sized sphere that can transform into a wheeled robot has been sent to the moon by JAXA, the Japan Aerospace Exploration Agency. A report in the journal Science Robotics says the tiny transformer's already been active, taking lots of photos while trundling around the inside of its lunar lander. The images were then transmitted to a second robot, which is designed to move around by hopping from one place to another, and then sent back to Earth. The engineers behind the project say these small light robots would be much easier to send into space and could independently explore cramped regions where bigger, bulkier robots simply can't reach. The problem with psychology is everyone's different, so gaining solid insights into the human mind and behaviour is difficult. Now, a report in the journal Psychology Today has tried to make sense of a number of high-profile tests trying to replicate past results which have failed to yield consistent outcomes. The resulting replication crisis has implications that might not actually reflect real phenomena and as a result has an impact on scientists trying to study human behaviour. The skeptic's Tim Mendham says work's now being done to try and get the basics right and find common human characteristics more likely to hold up generally under tighter scrutiny.
The interesting thing about psychology, you've got to sort of use the fairly loose definitions of hard and soft science, right? The hard science are those things you can empirically test and give a yes or no answer, or a replicable answer as well. So, yeah, physics and geology. And then there are the soft sciences, which is a pretty pejorative term, those things which are like sociology and, sort of political science and that sort of stuff. And I mean, medicine can be half and half. Medicine per se is obviously you can do a lot of testing and that's done, empirical testing, but there's also the human element.
Everyone's had a different life experience. Everybody has different genes. Everybody goes through different things in their lives and have different exposures and as a result suffers from different maladies and conditions and environmental factors. And
that's right. I mean, there are some aspects of medicine which you can test, physical aspect, but there's the human element which is the variable. Psychology is all human elements, right? And the question is how much testing and replicable testing can you do to move it into the quote hard, close quote science sort of category. And there are discussions about that, and it's sort of lumped in with sociology and things like that. One of the problems that's occurred actually recently is the reports about the difficulty in replicating past results. And it's finding that many of the studies that people relied on in the past do not yield consistent outcomes. Replication is a key part of science.
And societal norms are playing a huge role in it too. We're seeing that with the debate on trans people at the moment, where what was psychologically considered a correct response previously is now no longer considered a correct response.
Yeah, I mean, there's also all sorts of responses about genetic backgrounds to behaviour, various sort of behaviours as to what the foundation of these things. Is there a testable physical thing, or is it a highly variable thing like psychology? And they're saying that this replication crisis in psychology is a major issue. But then they're also looking at areas, well, let's cut it back to those things we can trust, that we sort of are pretty reliable. The first one is personality traits are largely stable in adults. In other words, you're not going to change your character that much when you get past your formative adolescent years. So you can almost think that trying to change someone's personality is going to be pretty difficult.
A leopard never changes its spots.
Yeah, that's right. That's one of the aspects that the people stay the same in their characteristics. Another one is that people are swayed by what they think most of their group thinks. So if they think their group would do this, even if they don't test it, if they think their group would do this, then they tend to go along with it. And that applies in many areas. Yeah, it applies in science and all sorts of areas which are a bit softer. They say people seek in subtle ways to confirm their pre-existing beliefs. This is a standard thing you spot in skeptical areas, confirmation bias, even if there's the evidence is sort of against it. If I want this result to occur, if I expect this result to occur, if this is preferable to my life philosophy, I will therefore tend to sort of lean towards it. That's when you reconstruct things, reconstruct the evidence around your belief. There's also people's choices are influenced by how options are framed, and this is classic in sort of questionnaires and questions and things. You could easily say that this meat contains 10% fat, but marketers would prefer to say this meat is 90% fat-free, which sounds a lot better. Right, it's the same thing, but it just sounds a lot better. So how you phrase a question, how you phrase the options people have can influence what they believe. And then there's other sort of things that they regard as pretty well agreed to. Some people will defer to authority, even that means hurting a stranger. But that's sort of the old electric shock sort of theories, etc., which were pretty weird anyway. People may recall saying something they didn't. Well, excuse me, this is skeptical territory through and through. You deal with it in a lot of things.
That's the Mandela thing, isn't it?
That's right. Your theory then was that people were convinced that Nelson Mandela died in prison. Then they heard about it. They knew when it happened, etc. Well, of course, he didn't. But people were convinced that this was happening, and they knew where they were when it happened, and blah, blah, blah. Memory is a very malleable thing. It's a very unreliable thing, which is why in court cases it's often argued about as to what people really saw. And over the years, even immediately, the memory can be tricky. You observe what you remember and miss out a lot of other things. Over the years, it can totally change. Discussing it with other people can totally change it as well. But that's one of the things they say is definite. Skeptics could have told you that in about 5 seconds. And the final one they list is that the scientific community has some ability to anticipate which findings will hold up. Now, whether they do that professionally or whether they do it from their own confirmation bias is a moot point. So there are various things, often failings in a way, of some of the psychological truths, but these are suggesting that these are the only possible psychological truths that you can rely on. And that makes psychology as a science a bit problematical. And I'm sure there's a lot of people out there who would, even psychologists, who would agree that there's a lot of wriggle room in scientific sort of proof and that sort of stuff. And that causes a problem in its own right too. So, how well can you go with those sort of attitudes?
That's the Skeptic's Tim Mindham, and this is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.